Hello everyone. So let's start over chapter number two, part two. So in the part one, we discussed TCP/IP model, we discussed OSI model, and then we discussed the definition of IoTs. We discussed the impacts of IoTs on businesses on our daily life as well. So in this part, we have two main agenda items, starting with the definition of, or you can say the architecture of IP mobility. We'll discuss IP mobility in detail, and we will discuss the characters of IP mobility as well. And the last is going to be the challenges created by internet and specifically the IoT. So, IP mobility architecture. If you remember in the last class, I just gave you a little overview of IP mobility. And what was that? Let's say, for example, if you live at Alpharetta, and for example, if you work at Lawrenceville, okay, so you live in Alpharetta and you work at Lawrenceville. So if you move from Alpharetta to Lawrenceville and you are basically connected with your cellular internet, or you can say you're using your data plan, so will you get a new IP address if you move to a new area? So the answer was yes. If you move from one location to another location, so there will be another router. You will and that particular router will have another set of IP addresses, so you will get a new IP address when you get to the new location. So we will discuss how this handover actually works. So let's start. So before we understand the architecture or how this handover works, we need to understand the characters of IP mobility, starting with the mobile node. So mobile node is basically, it could be a sensor, it could be your cell phone, which moves from one network to another network. So mobile node is basically a mobile device which moves from one network to another. So that's your mobile device or mobile phone which you carry. When you move from Alpharetta to Lawrenceville, that is your mobile node. So mobile device which moves from one network to another is mobile node. Then we have home agent. Home agent is basically a router. It's basically a router with some additional capabilities, with some additional resources, for example, databases and servers. So home agent is basically a router and with additional capabilities, and basically it manages the details of mobile nodes, associated mobile nodes. So what kind of details? So it manages their billing information, their location, etc. Okay, and supports the mobility as well. So what exactly the home agent, where exactly it is located? So let's say, for example, as just recall the same example. For example, if you live at Alpharetta, so and you have purchased a T-Mobile connection. So you have a T-Mobile connection and you live at Alpharetta. So T-Mobile, they have installed routers in various cities, Alpharetta, Duluth, all the way across the United States, of course. So for example, if you live at Alpharetta, so they might have one router there through which you can get services, and that router will become your home agent because your connection belongs to Alpharetta. So this home agent, it monitors your activities, makes your log, maintain your billing information, everything. Okay. If you move to another area, then home agent will be in contact with that area to find your location and all. Okay. So home agent, your a router, your home router, in fact, from where your connection belongs to. Next is the foreign agent. Foreign agent is again a router. It's again a router, and this particular router is, let's say, if you temporarily move to another area. So you live at Alpharetta. If you go to, or if you visit Lawrenceville, and still you will get you are still connected with the internet if you use your cellular plan. Why? Because you are getting services from the router at Lawrenceville in that particular city, and that router installed by again the same company, T-Mobile. This particular router will act as a foreign agent for you. Okay, so foreign agent is again a router of the location, your guest location, or you can say the location where you temporarily moved or visit. Okay, that's basically your foreign agent. Foreign agent could be a home agent for the people who live in Lawrenceville. So like your home agent could be the could act as a foreign agent for anyone who just temporarily move or visit Alpharetta. Okay, so foreign agent could be a home agent for those who just visit, who are visiting that area, and the home agent could be foreign agent for those who are visiting, I mean, your area, in fact. Next is the correspondence node or corresponding node. Corresponding node is basically a mobile node, mobile device that first initiates the communication. So for example, if your friend, he just makes you a call, so he will be, his phone or his device is going to be the corresponding node. Care of address is basically the IP address assigned by foreign agent. So if you temporarily move to a new area, so foreign agent will issue you IP address, and that IP address is called care of address. So now let's understand all these characters, how they communicate with each other, how this handover actually works. So for example, let's say, let's take the same example. So let's say you live at Alpharetta. Okay. Now that's basically your home agent, the router, your home agent, your router of Alpharetta, and you purchase your connection and all that stuff. But let's say you work at Lawrenceville. So let's say you work at Lawrenceville. So again, there will be a router, and for you, that router will be a foreign agent. So let's say this is you. You are basically connected with Lawrenceville router. So when you get connected with Lawrenceville router, foreign agent, they will issue you a care of address. As mentioned earlier, it's your IP address. After issuing you the IP address, Lawrenceville router will forward your care of address to your home agent. So your home agent can maintain your location, can find where exactly you are, can maintain your billing info as well. So let's say whatever you do here, like you consume the data plan and all that stuff, Lawrenceville location or this router will forward the information to home agent, so home agent can make a log. So now, for example, let's say we have your friend. So your friend is at, let's say, Smyrna. Okay, somewhere in Smyrna or any other city. So your friend is at Smyrna and he wants to call you. Now the thing is, he's also connected with his home agent or foreign agent, whatever. We don't have to worry about it. So he is known as now corresponding node, because he wants to call this mobile node. Because you are the mobile node, you will be the receiver. So what will happen? Firstly, this message or call will go to your home, from where your phone number belongs to. So your home agent knows your location through your care of address. So they will forward the call to that temporary location, or you can say your foreign agent. And then you will receive the call through your foreign agent. So this process goes on when somebody try to connect you outside your home agent network. Exactly the same example. For example, let me give you one more example to understand this hierarchy. So for example, this is your home. You live at Alpharetta. Okay. So you live in this location and you just went to your cousin's place at Lawrenceville. So you are at your cousin's home at Lawrenceville. Now what will happen? You just went here. Once you got here, your cousin just made a call to your dad or just to let your family know you are with them. So now your family, your siblings or your father or your mother, they know like you are at Lawrenceville. So let's say your friend who is in Smyrna, he wants to call to you. And for example, you don't have cell phone with you. So firstly, he will call to you at your home. Your father will let him know, hey, he's at his cousin's place. So then the call will be forwarded to your cousin's place, stuff like that. That's exactly the same way how the IP mobility works. Next is some challenges created by internet and IoTs. There are four main challenges. The first challenge is security challenge. There are a lot of security problems. Number one, the first security problem with IoT is the massive deployment of IoT's sensors. So that's a I mean, since we are massively deploying the sensors like everywhere, I mean, this a car might have 700 sensors. There are many examples of these IoT example. You can actually find a lot of examples of IoT. So of course, the thing is we are massively deploying IoT sensors. So the first problem is it is impossible to physically secure. Like provide physical security is impossible. So impossible physical security. Number two, the second problem is wireless communication. So since it's a wireless communication, which is open for all type of adversaries, sniffing, man in the middle attack, MIMA, or man in the middle attack, interception, all these kind of things are possible. DOS attack is again possible, etc., etc. There are many attacks are possible. And why we cannot easily overcome them, avoid them? Because of the low cost. Because now the challenge is we need to actually come up with the low cost IoT sensors, and security comes with cost. So if you decrease the cost, automatically we are compromising over security. That's the problem. So these are the three main problems. No physical security, like impossible to physically secure, wireless communication, and we cannot use typical cryptographic algorithms and all that stuff because of the low cost. Next, the privacy issue. You are always being tracked. All your activities will be are being monitored. So always being tracked. Other than that, you can say your online info trading. So whatever you type on Google, or whatever you do search on by using Google engines, or I mean search engines or anything, you are leaving footprints, and they sell your information to third parties. This raises a lot of questions. The first question is, who is collecting my info? Number one, that's the first question. Number two is, are they authorized to collect info, to collect my info, my information? Are they authorized to do so? Then third is are they selling my info? Fourth question is, are they selling my info? Fourth question is, what exactly they are monitoring or collecting, like whether they are making patterns, online profile, what exactly they are doing. Now there are many challenges. For example, a company, let's say a company, let me just give you an example. Let's say a company is TikTok. TikTok is a mobile app. So, and this is basically a Chinese company, a Chinese product, in fact, and they do their business in US as well. So there are a lot of concerns, like what kind of information TikTok is collecting, because if you have any application installed on your mobile device, so just imagine they can collect anything from your computer. What kind of information they are collecting? Are they authorized? These are, just the concerns. Now the biggest problem here is federal government. They cannot force TikTok, or they cannot enforce their policies on TikTok, because there are plenty of things, like they cannot do a physical audit of the servers, what exactly they have collected, are they selling information or not. Like there are plenty of things. Why? Because it's a foreign, the server might be located in a foreign country where they don't have jurisdictions. So federal government cannot enforce the companies who are working abroad, or they cannot force them to compliance with their policies. That's one of the problem. Other than that, interoperability is another problem. Interoperability means, for example, we have two vendors, let's say Dell and, for example, HP. So if you have a Dell computer and somebody has an HP computer, if Dell decided, hey, I want to use my own infrastructure, I'm going to use my own communication protocol, same is the case with HP. So the people who have the cross product, they cannot even communicate with each other. What does it mean? It means if they are not interoperable, so the guy who has a Dell computer can only communicate with the person who has a Dell computer. If you want to communicate with HP, the client or person having HP computer, you need to buy HP product. Of course, it's a mess. Same is the case with IoTs. With the IoTs, people are basically they're coming with different operating system, and they're coming with different encryption schemes. They're coming with different kind of standard as well. Now, there are two organizations. One is called IETF, Internet Engineering Task Force, and ITU, International Telecommunication Union. So, Internet Engineering Task Force and International Telecommunication Union, they have formulated a comprehensive policy. They have formulated a comprehensive policy for all vendors. Okay, so vendors, they have to compliance with the policy for IETF and ITU in order to operate, in order to use internet, in order to use IoTs. And that particular policy, it encompasses the TCP/IP protocol, like all these sensors, or the devices, they have to have the TCP/IP protocol exactly common. There are operating system structure, like you can have your own GUI, you can have your own new features and stuff like that, but there are few operating system structures, services, in fact, 6 main services, type of system calls, stuff like that. Those particular things are in common. You can have your own optimization algorithms, but not the communication algorithms. So optimization algorithms, or you can say your data searching algorithms and stuff like that, could be different. But if you come up with a new algorithm, this particular algorithm needs to be passed by NIST first. If it is a security algorithm, of course, NIST has to pass that. Once NIST pass this algorithm, it will be forwarded to IETF and ITU. Okay, so it's kind of a process. So some people, they think it delayed their product to launch to the market. Let's say I just came up with a novel idea, novel algorithm. So if I submit to NIST, and then NIST will forward to IETF, then ITU, and then it will be time to market. There are, for example, if the same idea is submitted by two competing companies to NIST, there is a possibility one of them they got it through early, and it might actually bring a breakthrough even sometime. So for interoperability, all these vendors, they have to compliance with the comprehensive policy formulated by IETF and ITU if they want their products to transmit the data over internet. The last but not the least is the legal and regulatory compliance. That's a very big issue. The big issue is that, for example, the legal issue, there are some taxation issues, sales tax. Like, for example, if anybody or a company whose server is located in Germany, for example, if the server is located in Germany and they're basically selling products in US, will they pay taxes? If they pay taxes, what will be the process? Okay, because they are making business from United States. That's a very important thing to understand. Other than that, for example, in United States, we have a lot of billion-trillion-dollar companies. For example, Facebook is working in United States, in Germany. So according to German law, Facebook cannot collect the personal information, or they cannot sell the personal information of German citizen. So they cannot actually take out their information and sell it to a company in Italy, for example, or maybe sell the information to US. So if they collect information in Germany, it has to be consumed in Germany. Like, the companies or the data analytics companies must be in Germany if they want to consume the information. Sales tax is the biggest problem. Other than that, some IT laws, because new things are coming up. There are new e-commerce business, the models like business to consumer, consumer to consumer, stuff like that. So how to protect how to ensure security and privacy of citizen, their information and data. So IT laws are basically very important. These laws govern, or these laws sometimes change very quickly. We have to change the laws according to what the you can say what kind of new product is coming up in the market. But these laws should not be that strict as well. If you make strict laws, what will happen? Companies will actually pull out. They will go out from your country, and it could be a setback to your economy. So making of these legal law, the IT laws and all that stuff is not that easy job. So it's a very complicated process, in fact. So that's it about our chapter number 2. We will discuss chapter number 3 and lab number 2 in our next class. Thank you.